Hey, Mr. Myers here. But before we get started on talking about linear systems of equations, I need to talk about the standard form really quick of a linear equation, which is ax plus by equals c. So what does that mean? That means we have maybe a value for a, maybe it's 3x plus 2y equals 7. Now we can put this in the slope form, which would basically subtract 3x from both sides. And we'll get 2y equals negative 3x plus 7. And then we just divide everything by 2 in order to get the 2 over there. And we'll have y equals negative 3x over 2 plus 7 halves. And that's the same thing as this up here. The caveat is that this cannot be a negative number. So if somebody says, hey, I need you to write this in standard form, and you had, let's say, a positive 3x over 2, well, you have to first subtract 3 halves x from both sides, and you're going to get negative 3 halves x plus y equals 7 halves. Well, we can't have this negative here. So what we need to do is multiply both sides of this equation by negative 1. Why are we doing that? Well, if we multiply by negative 1, negative times a negative makes us a positive. So we have a positive 3 halves x. Negative 1 times a positive y, it's going to be a negative y. Whatever you do to one side of the equation, you need to do to the other. So you have negative 1 times 7 halves, that's negative 7 halves, Mr. Myers, 7 halves, negative 7 halves. So let's say that I have a real-world situation here. I decided to see how far I can run before somebody on a horse is going to outrun me. And I can measure that with the equation d, my distance, equals, and I can run a good 0.2 kilometers for every minute. Now the horse, he's a little bit faster. He can run 0.5 kilometers every minute, but the person who is going to be riding the horse, it takes them 6 minutes to saddle the horse. So we got to take that time into consideration when writing our formula. So how are we going to show that 6 minutes is going to be lost? We're simply going to do t minus 6, that's 6 minutes. Graphically, if I look at these two linear equations, I can put them here. My y is my dependent variable, that's the distance. My independent variable that will change is going to be the x, or the time. So time is running across here, and then the y is going to be my distance. So this green line here is my running speed. And as you can see, 4 minutes have passed, and I've run, how much? 0.8 kilometers. At 10 minutes, where the two lines meet, both of these have the same point. That means at this point, this is where the equations together are true, which means at 10 minutes, we would have run 2 kilometers to meet each other before the horse starts winning this race. So let's say instead of graphically, we want to do this algebraically. Excuse me. So we can do this multiple ways using these equations. Since both of these equations equal the same variable, oops, I did not mean to do that. So both 0.2t and 0.5 times t minus 6 equals d, we can set these two equations equal to each other. 0.5 times t minus 6. And now we can just solve for t. So what do you think that's going to be? Well, we have to just bring down our 0.2t here, and we need to multiply this 0.5 throughout. And that's going to be 3. I'm going to subtract 0.5t from both sides. 0.2 minus 0.5 is a 0.3, and that is a negative 0.3. T equals a negative 3. Divide both sides by a negative 0.3. And my T is going to be 10. Now that I know how much time has passed for both of these equations to be true, I can simply go in and plug in this 10 in either one of these equations, and I'm going to get the answer for how much distance has passed. This is the simpler of the two, so I'm just going to plug 10 right here and get d time equals 0.2 times 10. So my distance is going to be 2 kilometers. So my point is going to be, if I remember correctly, the x is 10, and the distance would be 2 kilometers.